Hello, and welcome to American Public University System Symposium on Current Science Knowledge in Support of Popular Science Writing. My name is Shane Sexton, and today I'll be reviewing the book Saving a Million Species, Extinction Risk from Climate Change, edited by Lee Hanna. Displayed are our discussion topics for this presentation. We'll start with a background on Dr. Lee Hanna, then a background on the book itself, some key points of the book and what current science has to say, what impacts the book has had on the field of environmental science, and sources cited. Dr. Lee Hanna received his bachelor's in biology at UC Berkeley, his master's in physiology at University of Hawaii, Burns School of Medicine, then finally receiving his PhD in environmental science and engineering at UCLA. Dr. Hanna is a senior fellow in climate change biology at the Conservation International Betty and Gordon Moore Center for Science and Oceans, and an adjunct professor and lecturer at Burns School of Environmental Science and Management. Dr. Hanna has authored and co-authored numerous research papers on climate change, conservation, and biodiversity. The book, Saving a Million Species, Extinction Risk from Climate Change, again was edited by Lee Hanna. It was published in December of 2011. The book contains a collection of research and studies from over 30 scientists that are considered experts in their field of study. The book examines, analyzes, and explains the science behind Thomas et al.'s January 2004 publication in Nature, Extinction Risk from Climate Change, and attempts to answer the main question of that paper: how many species may perish as a result of climate change and associated threats. The book is made up of 20 chapters and divided into 6 parts. Part 1, Introduction, looks back at the Thomas et al. Paper that sparked worldwide attention on extinction risk from climate change. Part 2, Refining First Estimates, looks at recent developments as a comparison to the original work. Part 3, Current Extinctions, discusses current extinctions and how or if they can be contributed to climate change. Part 4, Evidence from the Past, looks at paleoecological records to see if extinction in the past can be linked to climate change and what indicators from the past we should be looking for. Part 5, Predicting Future Extinctions, looks at the evidence and takes on a risk assessment of various different biomes and their inhabitants, and their likelihood of extinction due to climate change. Part 6 discusses possible management strategies for an assortment of environmental situations and conditions. Next, we'll look at some key points made by the book and how they relate to science today. In Parts 1 and 4, studies of our planet's climate levels from millions of years ago were compared to extinction rates through various fields of time. The book concludes that climate change alone will not produce a mass extinction result as those from the Big Five extinction events, but findings from then and current research have determined through fossil extraction that an increase of more than 5 degrees Celsius pre-industrial levels would likely result in the mass extinction of many species. However, the threshold of degree up to that 5 degrees Celsius in which an extinction event would occur is still very controversial. Next, we'll take it from the past and look to the future. In Part 5, Predicting Future Extinctions, modeling efforts of species extinction will always be controversial due to the multitude of different and changing data collected. Species dispersal is no exception. However, the book does address how species dispersal can have impacts on species interaction, resulting in cascading extinctions on local species that rely on one another. More current studies have shown that species migrating to adapt to climate changing, such as non-native predators and species competition, can affect the local environmental community, resulting in habitat destruction and biodiversity loss, which greatly adds to the risk of species extinction. Our last key point I would like to discuss is Part 6's conservation implications. From the many discussions in the book to current research today, it shows us that climate change impacts on species is nonlinear. There is not, nor will there ever be, a quick fix to the issue of climate change and how it will impact every species. Proper adaptive management strategies and increased conservation legislation geared towards reducing our CO2 emissions, restriction on deforestation, and protecting biodiversity in the wake of climate change are the key takeaways from all the contributing authors of the book. So now let's look at the impact this book has had. This book has had major impacts in the field of environmental science. By bringing light to the seminal contributions of Thomas and his colleagues' 2004 paper, it analyzes and consolidates the numerous studies and evidence in support of climate change to be used for future research. It helped change the way the International Union for Conservation of Nature evaluates species risk in relation to climate change when placing a species on the red list. It helped establish new risk assessment models for future impacts from climate change on extinction risk species. And it established conservation and policy implications to aid in legislative conservation efforts in both the state and federal components. I want to thank you all for your time and participation in American Public University System Symposium. Again, my name is Shane Sexton, and this concludes today's session on current science knowledge in support of popular science writing, a review of Saving a Million Species, Extinction Risk from Climate Change.